This video is going to have a look at an example of how to resolve a set of simultaneous equations algebraically using the substitution method. To use the substitution method, I would recommend completing the following steps. The first step is to rearrange the equation if needed, and you would rearrange the equation to make sure that you had a variable as a subject. So that means the equation would be in the form of x equals or y equals, or it could be another letter, it could be a equals, but making sure you've got a variable as the subject of that equation. The second step is then to substitute that equation from step 1 that has the variable as the subject into the second equation to form a new equation. The next step is then to solve that new equation formed in step 2, and that will allow you to identify one of the variables. So if we're looking at x and y, you might find an x value by solving that equation. Once you know one of the variables, you can take that variable and substitute it back into one of the original equations, which will enable you to find the second variable. Once you know both variables that you're looking for, then you can write the answer. So let's have a look at how do we apply these steps in an example. So in the example, we want to solve the set of equations simultaneously to work out their point of intersection. And the equations are 4x plus 3y is equal to 29 and 2x plus y is equal to 13. Now our first step is to check to see whether we have an equation that has a variable as the subject, and if not, rearrange one of the equations. So here we've got 4x plus 3y and we've got 2x plus y in the second equation. So none of those equations have a variable as the subject. So we need to rearrange one of those equations to make sure that it has a variable as the subject of the equation. And the one I'm going to choose to rearrange is the second one. I chose the second one because it already has a variable by itself. So it'll be easy to be able to make that the subject of the equation. And to make it the subject of the equation, what I need to do is I need to remove positive 2x from that side of the equation. And I do that by doing the opposite of positive 2x. And the opposite of positive 2x is negative 2x. So I subtract negative 2x from the left-hand side, and then I need to do the same thing from the right-hand side. So that then makes my new equation y equals negative 2x plus 13. So now I can see that I have got an equation that has the variable as a subject. So I can go ahead and substitute in now that new equation into the other equation from the original set of equations. So to complete that substitution, I'm going to take my y value from my second equation, so negative 2x plus 13, and I'm going to substitute that in for y in my other equation. So when I substitute it in, it is going to be 4x plus 3y, and instead of using y, I'm going to substitute in negative 2x plus 13, and that's going to be in brackets, so negative 2x plus 13, and that is going to equal to 29. So now I can go ahead and solve that equation. First, I'm going to expand my brackets. So 4x plus 3 times negative 2x, which is going to be negative 6x, plus 3 times 13, which is going to be 39, is equal to 29. So collecting like terms, negative 2x plus 39 is equal to 29. So now I want to look at rearranging to be able to solve, and the first part of the equation I want to rearrange is my plus 39. Opposite of plus 39 is subtract 39. So I want to subtract 39 from both sides. So negative 2x is going to equal to negative 10, because 29 minus 39 is negative 10. So now I want to get x by itself. So I'm going to divide both sides by negative 2. So negative 10 divided by negative 2 is going to equal to positive 5. So my x value is going to equal positive 5. So now that I know the value of one of my variables, being x is equal to 5, I can go ahead and substitute that back into one of the original equations to be able to work out what my y value is going to be. Now to do that, I'm going to substitute it into my rearranged equation. So y is equal to negative 2x plus 13. So when I substitute in x is equal to 5, it'll be y is equal to negative 2 times by 5 plus 13. So negative 2 times 5 is negative 10. Negative 10 plus 13 is going to be 3. So my y value is equal to 3. My x value is equal to 5. So I can write that as my final answer, 5 and negative 3. So my solution to the set of simultaneous equations is 5 and negative 3, and that will be my point of intersection between my original two lines. So that is an example of how we can use the substitution method to be able to solve a set of simultaneous equations.